If 2 notebooks cost 30 rupees, the cost of 3 notebooks will be 45 rupees and that of 4 will be 60 rupees. On the other hand, if 2 men build a wall in 6 days, 4 men can complete the same wall in 3 days. What do these scenarios indicate? In our daily life, we come across many such situations where one quantity depends on another. In such cases, it is seen that the change in one quantity brings about a corresponding change in the other too. Such quantities are said to be in variation or proportion with each other. In this module, we'll understand the first type of variation, where 2 quantities are directly related to one another, such that an increase in one causes a corresponding increase in the other, and a decrease in one causes a corresponding decrease in the other. This is known as direct variation. Let's take a look at an example. Before the new academic year begins, Mr. Kapil Kumar, the school principal, wants to set up a computer laboratory for his students. He checks the school records to find out the maximum number of students in each class. He finds that there are a maximum of 32 students in classes 8 and 9. He looks at the reserves left in the school fund and decides that he'll need to buy enough computers to be shared between 2 students in each class. How can Mr. Kapil calculate the number of computers required for 32 students? Since the school budget allows for 1 computer to be shared between 2 students, Mr. Kapil will need 2 computers for 4 students, 3 computers for 6 students, and so on. Looking at the table, we can see that when the number of students, x, increases, the number of computers, y, increases, and vice versa. If we take the ratio of x to y, we see that it is a constant. In this case, 2. If y increases in such a way that the ratio of x and y remains constant, we say that x and y are in direct proportion or variation. Therefore, for 2 given quantities, in this case number of students x and number of computers y, x and y are in direct variation if there is a non-zero constant k, such that x is equal to k times y. The relationship is denoted as x is proportional to y. The value of the constant k can be found by dividing x by y. Let us now see if this relation holds true for each of these instances. Since the relationship holds, we can say that the number of students and the number of computers are in direct variation. As for the number of computers Mr. Kapil needs to purchase, the knowledge of direct variation will help him get the answer. We know that here the number of students and the number of computers are in direct variation. Their ratio is a constant, which in this case is 2. On substituting the number of students in the equation and simplifying further, we can find the number of computers required. Thus, Mr. Kapil needs to buy 16 computers for 32 students. For any 2 quantities that are in direct proportion, we can use this relation type to cross-multiply and then solve for an unknown value of one of the quantities.